Building a wooden vessel the size of a four-story building by hand is a staggering task. Doing it on dry land, miles from any ocean, using only spoken instructions, seems like an impossible mandate. The Book of Genesis provides the specific blueprint for the structure, 300 cubits long, 50 cubits wide, and 30 cubits high. Converting those ancient units to modern measurements reveals a ship 135 meters long. That is nearly the length of a full American football field, with a height equivalent to a four-story building. Beyond the scale, the engineering secrets are hidden in the proportions. Those dimensions, 300 by 50, create an exact 6-to-1 length-to-width ratio. This specific geometry concentrates mass at the base, creating a low center of gravity. This chart demonstrates how that ratio responds to violent seas. When massive wave pressure strikes a broadside hull, the low center of gravity forces the ship to automatically right itself, preventing it from capsizing. These ancient dimensions align with the modern naval standards required for a vessel to remain upright and stable during a global catastrophe. The Ark's balance was mathematically precise, but its survival also depended on the durability of the wood itself. The ancient texts identify the material as gopher wood, which many botanists believe refers to a dense, resilient timber like the cedar tree. Another possibility is that gopher wood was a prehistoric species, now extinct, that possessed natural water-resistant properties exceeding any timber currently known to science. To prevent the wood from saturating, the builders coated the entire hull, inside and out, with bitumen. This is a thick, natural asphalt that serves as a premier sealant. Beyond waterproofing, the bitumen provided a critical engineering advantage: flexibility. This chemical coating allowed the rigid timber to bend and absorb the immense pressure of the ocean without the hull shattering. The combination of dense wood and a flexible sealant created a reinforced, living armor, capable of weathering extreme hydraulic forces. A floating fortress is only effective if its inhabitants can survive the internal logistics. The primary challenge was fitting a global population of animals into a single structure. The ancient Hebrew text uses a term that translates to biological kinds rather than individual species. For example, instead of every modern breed of dog, the builders only needed a single ancestral canine pair. This classification significantly reduces the required volume. Modern research estimates the Ark needed to hold about 1,000 core kinds, or roughly 6,800 animals, a number that fits comfortably within the ship's 135-meter hull. Space was further optimized by bringing juvenile animals. Young animals occupy less floor space, require fewer calories, and produce far less waste than their adult counterparts. Hygiene required an automated waste system. Angled floors used gravity to channel waste into vertical chutes and a bottom reservoir. Similarly, the roof filtered rainwater through sand and charcoal, routing it via branching pipes to provide fresh water to every stall. Gravity provided the power for the Ark's internal functions, allowing a crew of just 8 people to maintain a specialized, highly organized survival facility. While food and water were managed, the air posed an invisible threat. In a sealed environment, the combined respiration of thousands of creatures would cause carbon dioxide and ammonia to reach lethal levels within hours. The solution was the tsohar, a narrow 1-cubit opening at the top of the Ark. Often thought of as a window, it functioned as the exhaust for a natural ventilation engine. Animal body heat created a chimney effect. Warm air pushed upward and exited through the tsohar, creating a pressure vacuum below. This automatically pulled fresh air through intake ducts, ensuring a constant supply of breathable air without mechanical fans. To navigate the dark hold and care for the animals, the crew used ceramic oil lamps. By strategically positioning these lamps near water masons, they could also regulate the humidity levels needed for different species. Through the use of natural physics, the Ark maintained its own atmosphere, functioning as a self-regulating biosphere in the middle of a global storm. While the hull weathered the exterior storm, the crew faced a different pressure inside. 8 people were confined to a lightless wooden box for 370 days as the world they knew disappeared. The noise would have been constant. Researchers estimate the interior sound levels reached 85 decibels, comparable to a modern industrial factory, due to the combined roar of the storm and thousands of panicked animals. To manage this, the human quarters were positioned on the third and highest deck, the furthest point from the lower animal holds. Some researchers hypothesize that the crew may have used natural insulating materials in the walls of their quarters to create a necessary pocket of relative silence. Sanity was likely maintained through a rigorous, military-like routine. The daily tasks of clearing drains, inspecting the animals, and managing the lamps provided the structure needed to prevent mental collapse during the year-long voyage. This combination of spatial zoning and disciplined labor was the only way the crew could survive the extreme psychological strain of the journey. The voyage ended when the Ark's massive hull finally scraped against the peaks of Mount Ararat. The release of the animals triggered a massive biological expansion. From those 6,800 ancestral archetypes, life rapidly branched out and speciated, eventually forming the vast biodiversity of the modern world. The world they stepped into was an ecological wasteland. With vegetation destroyed by the flood, foraging was nearly impossible. At this point in the narrative, humanity received permission to consume meat for survival. This dietary shift explains why Noah was instructed to bring 7 pairs of clean animals instead of 2. Those extra animals served as a calculated reserve for food and ritual use in a barren environment. The Ark represents a convergence of strategic planning and biological foresight. Its design utilized engineering principles that remain fundamental to ship stability and survival systems today.